we saw in our last topic that we can use regular trig ratios to solve for missing sides and angles and triangles. So what we're going to look at today is what happens when we don't have a right angled triangle. So some of the harder questions we looked at before would have been like two triangles side by side. So I mentioned that when you're doing one of these, if I gave you this angle down here, and let's suppose we did this side over here, and maybe the question would be, what is this side going to be? So quite often with questions like this, you're going to be given angles and sides and so on. We're going to be looking for the missing side. So using old SOHCAHTOA ideas, what we'd have to do is probably find that height. We'd use sine 30 would equal h over 15. And then once we have that height, we'd then use sine again to solve for the side that we're looking for. So what we're going to see today is we can actually do something new called the Sine Law, which is a different formula that we can actually solve for that all in one step. So it ends up actually being a little bit easier than doing SOHCAHTOA stuff. So let's look at this example, and we're going to do it first using regular sine, and then we're going to use the Sine Law afterwards to see how it's going to be easier. So if we cut this in half again into two triangles, we can actually solve for that height by doing the Sine Law. And actually this one's not going to work as good. Let me go back to this title page one. I think this would be a better example. So let's solve for height. So sine 30 equals h over 15. So if we cross multiply those, we'd have h being 7.5. Then we'd use Sine Law again. So we'd have, regular sines, we'd have sine 45 is h over what we're looking for. Let's call that side x. But we know h is 7.5, so we could go 7.5 divided by sine 45, and that would actually give us 10.6. So it works not too bad to do it in two steps, but what we're going to see is the Sine Law is actually a little bit of a quicker way to do things. So the way the formula is actually derived, it's doing exactly what we just did. So I'm going to redo this question, but I'm just going to use letters. So if we look at this one, we know that sine A from sine A would be h over side B. And then we also know from the other side, we'll go sine 25 would equal h over side A in this case, right? 15 would be side A, so opposite over hypotenuse. So if both of these could give us h, we could actually solve h to be b sine A, and this one would be a sine B. I'm going to use just our letters, not numbers, just to kind of show you where the formula comes from. And then, because they're both equal to h, we can make them equal to each other. So we'd have b sine A would equal to a sine B. And just to make it a little bit easier to remember, we cross multiply just to get things the same. So if we brought the a over, we could have sine A over A, which would equal sine B over B. And we could actually redo this question if we were to draw it a different way. Instead of the height being up and down like I drew it there, if we were to draw it so that we'd have our vertical height something like that, we would have A and C it would work with, or B and C instead of A and B. Or if we did it the other way, we would have B and C. So for the Sine Law questions, it doesn't matter which two sides of the triangle you use, you basically get similar formulas. So if we go back to our title page, these are the formulas we're going to actually work with. And they are just the sine of the angle and the side across from it. We just set up the ratios that way. And it doesn't matter whether we put the angle on top or the side on the top. Typically it's nice to do, if you're looking for an angle, start with the angle on the top. If you're looking for a side, start with the side on the top. That's generally the way I do it, and then it helps your cross multiplying a little bit later on. So let's actually solve this question now using the Sine Law. So if we have the Sine Law, we can actually get this question a lot easier and faster than we did before. So for this first one, we're looking for side C. So let's start with that on the top. So we have side C, and we need to go across the angle across from it. We don't have angle C, but we know that if this is 35 and this is 25, those add up to 60. So that means angle C had to be 120 degrees to add up to 180. So even though we don't know that angle, we can usually figure it out pretty easily. So that's C over sine 120, and then we'd use the one that we have across from each other, which is A and the 15. So we go 15 over sine 35. And that's it. So now when you're cross multiply the two that you have. So 15 times sine 120 and divide by the one across from your C, which would be sine 35. And type that in and you're done. So 120 sine times 15 divided by sine 35 gives us an answer of 22.6. And it'd be meters in this case. So the sine law is actually a faster, easier way to do a lot of these questions. So this question here you can see is basically what I just did. It's basically if we use that height, we can actually come up with it. So since I've already did it, I won't bother redoing it here, but we do the same thing. Solve it for h, make h equal to each other, and that would just give us our sine law formula. And it doesn't matter which two sides you use, we just need any two of the three. So we don't use all of this formula, you basically just pick two parts of it, whether it's a and b, or a and c, or b and c, it'll work either way. So there's our two formulas, and once again, like I said, you want to make sure you do the angle on top if that's what you're looking for, or the side on top if you're looking for that. So let's try this one. We got angle R we're looking for. So we don't really care what the letters are, the ABC, we just got to remember we got to go with pairs. So we have R and the 41 together, and we got 39 and the 28 together. So if we're looking for R, we'd write it as sine R over 41 equal to sine 39 over 28. So as long as you have those angle pairs across from each other, you're good to go. So when you multiply this one now, you'd have sine 39 times 41 and divide it by 28. So that gives you 0.92, but that's what sine R is equal to. So what we want to do, just like we do with SOHCAHTOA, if we're looking for angle R, we actually have to put in second sine. So on your calculator, go second sine of that answer, and we'll get an R of 67 degrees for our final answer. So if we know that that one's 67, we could then use 180 rule to figure out P, or if we're looking for side P, we could use the sine law again over and over. So once you get used to the sine law, it's pretty quick and easy to solve for any side or any angle. So here's another one. We're looking for side X. So we have 49 and X are the opposites, so we go X over sine 49. And we'd have 10 over sine 63. Cross multiply those. So sine 49 times 10 divided by sine 63 gives us an answer of 8.5 if we round it off. Okay, here's one more. If we're looking for side A, so we're looking for side A over there. So once again, this is one of those ones where we would have a missing angle. So we'd have A over sine 42, so that's good. The side that we have is 22, but we need the angle across from it, which we don't have. But we can use the 180 rule once again. So 180 minus 75 minus 42 gives you 63 degrees. So put that in your sine law formula. So we'd have sine 42 times 22 divided by sine 63. And that gives us an A of 16.5 centimeters. One last one. So here we have a question where we got two boats. And the question is, what's our distance between the two boats? So we could do this one actually just using regular SOHCAHTOA, but let's try it with the sine law. So you can see if we're looking for side X, we're going to need to know the angle across from it. And if we have an angle like the 30 in the triangle, we're going to need to know the side across from it. So let's try it with the sine law so you can see we're missing a couple of things here. So the first thing we want to do is let's use regular trig to figure out what that side Y would be. So based on our little triangle, we would have sine 45 equals opposite, which is 100, over hypotenuse, which is Y. So if we rearrange those, we'd have 100 divided by sine 45, which gives us 141. So that's our length of that side of the triangle. The other thing we can do is we can figure out our top angle. So if this bottom angle is 45, that means that top angle would also have to be 45, because this is 90 and they add up to 180. So now we can use the 90, the 30 degrees over here. So that means the total would have to be 60. So 60 minus 45 would give us 15. And now we're good to go. So we have our triangle. We can actually use the sine law. So we'd have x over sine 15 would equal 141 over sine 30. So if we cross multiply those out, so we'd have 141 times sine 15, divide that by sine 30, and that gives us 73.2 feet. So that would be our distance in between those two boats. So you can see sine law still works well with SOHCAHTOA, but it's obviously a little bit easier in most cases. One last thing before we end. Often some people say, well, if I can use the sine law, would it actually work for a 90-degree angle triangle? So let's just go back to regular 90 triangle, and if I gave you this angle, let's suppose it was 30, and if I gave you this opposite side to be, let's say it was 8, and the question is, what's the hypotenuse? So let's try this with the sine law. If we use the sine law, we'd have, if we call that x, we'd have x over sine 90 would equal 8 over sine 30. So if we actually cross multiply those, we get 8 times sine 90, but on your calculator, when you type sine 90, we get a weird thing that happens. Sine of 90 is actually just 1. So we actually just get x equals sine 30, 8 over sine 30. So we don't need to do anything extra. And if we would have just done this with regular sine, we would have had sine 30 equals opposite 8 over hypotenuse. You can see these are the exact same things. So the sine law actually works for any angle, where SOHCAHTOA, opposite over hypotenuse, works only for a 90-degree angle, but they both do the same thing. So some people actually prefer just use the sine law all the time, whether it's a 90-degree angle triangle or not, and it usually works well. So that gives you an option. And that's all.